Hi everyone, let's work on the second part of chapter 5 review quiz. We're going to start with question 13. The first part of the question is asking us to find the maximum number of zeros. To answer this question, you just need to know the degree of this function. So the term with the highest power gives me the degree of the function, which is 6. Then how many positive real zeros we have? You need to check for the sign changes in the terms of this function. The first term is positive, so we go to positive to the next term, so there's no sign change. But then from positive, we go to a negative term. So there is one sign change. So we say there is one positive real zero here. How about the negative real zero? You need to find f of negative x. To replace negative x to the function, this will be negative x to the power of 6 plus 7 times negative x to the power of 4 minus 8. So when you simplify, this will be x to the 6, this one will be 7x to the 4, and negative 8 is next. Now check for the sign changes in f of negative x. Positive to positive, positive to negative. So there's only one sign change. So we have one negative real. Let's look at this example that I just made for you. So I have this function. I want to know how many positive real zeros I have. Check for the sign changes. Positive, negative, negative, positive, positive, negative, and then negative and negative. So I have 3 sign changes. So I'm going to have 3 positive zeros or 3 minus 3 minus 2, which is equal to 1. So we have either 3 positive zeros or 1 positive zero. Then look for f of negative x and simplify. How many sign changes do we have? In this case, I have only one. I have only one negative zero. If you have more than one, let's say 3, make sure you subtract 2. You will have either 3 zeros or 1 positive zeros. Okay, so next question. We are trying to find the zeros of this function and then write it in the factored form. We have to use rational zero theorem because I'm not able to factor this function easily. So you're going to use this method. Find factors of the constant term, find the factors of the first term, and then you're going to divide them. You need to consider the positive and negative cases of all these numbers. Since the denominator is 1, I don't have to divide anything, so this is just a list of my zeros. Now, I need to check out of all these zeros, which ones are really a zero of the function, which ones are the correct zeros of the function. So there are 2 methods. I'm going to explain the first method here first. So I need to know if 1 is a zero of the function or not. If 1 is a zero of the function, this function is dividable by x minus 1. That means this is a factor of the function. So how do I check that? Set this equal to 0 and x is equal to 1. This is my corner number. And divide the function using synthetic division. If the remainder is 0, this is a factor of the function, and 1 is a zero of the function. So list the coefficients 1, 1, negative 11, negative 9, and 18. Bring the 1 down. 1 times 1 is 1. 2 times 1 plus negative 11 times 1 plus negative 9 times 1 plus 18 is 0. So the remainder is 0. That means function is divisible by x minus 1. So 1 is a zero of a function. As a result, x minus 1 is a factor of a function. But what is the other factor of the function? How do I find the other zeros? You're going to use this part of the division. 18 is the constant term. This is coefficient of x to the power of 1, coefficient of x to the power of 2, and coefficient of x to the power of 3. So I can write the other factor of the function, which is x to the 3 plus 2x squared minus 9x minus 18. Now, find the other zeros from this part. Am I able to factor this? Yes. The first group and the second group. First group has x squared in common between them. So I factor that, I will have x plus 2 left. Second one, factor negative 9. We'll have x plus 2 left again. Now, x plus 2 is the common term, so factor this one out, and we'll have x squared minus 9. X squared minus 9 is difference between two perfect squares. So this is x times x. This one is 3 times 3. So I can factor as x minus 3 and x plus 3. I already had x plus 2 here and x minus 1 as the other factors. Now, just set each factor equal to 0 and solve for x. This equal to 0, one of the zeros is 1, which we already had found it before. X plus 2 equal to 0, the other 0 will be negative 2. X minus 3 equal to 0, 3, and x plus 3 equal to 0, negative 3. So these are the list of the zeros of the function, and the factored form is already here, which we did it before. So this was the first method. Now, what is the second method to find out? The second method is this. If I want to know 1 is a zero of a function, just check f of 1. If 1 is a zero of a function, f of 1 will be equal to 0. So let's try that. Replace 1 here. 1 to the power of 4 plus 1 to the power of 3 minus 11 times 1 to the power of 2 minus 9 times 1 plus 18. When you calculate, this is equal to 0. So 1 is a zero of the function. Then I have to try f of negative 1. When you replace that, negative 1 to the 3, negative 11, negative 1 to the 2, minus 9 times negative 1 plus 18. This is not equal to 0. So negative 1 is not a factor of a function. Then I have to do that for all those numbers, f of 2, f of negative 2, f of 3, negative 3, then f of 6, f of negative 6, and so on. So I have to try see if they are equal to 0 or not. So we see that f of 2 is not equal to 0. When you try that, you will see f of negative 2 is equal to 0. This one is equal to 0. This one is equal to 0. And since the degree of the function is 4, and I already found 4 of them, I don't even need to try the other ones because we can only have 4 zeros. Otherwise, you have to try all of them. So you can choose between these two methods and see whatever is easier, you can choose that. The next question is asking us find the remaining zeros of f if these are given to us. These zeros are given. Degree is 6, that means I will have 6 zeros, but 4 of them are given. This one, this, and this one. How do I find the other one? Look at the zeros. I have two complex zeros or imaginary numbers here. If I have a complex zero, the conjugate of that number is also a zero of a function. What is conjugate? If I have a plus bi, this is a complex number, and conjugate of that is a minus bi. So just change the sign of the term with the I, and that's going to be the conjugate. So if I have 4 plus 9i as a zero of a function, then 4 minus 9i is also a zero of a function. And this one, negative 7 plus 3i will be the other zero of the function. And that's it. The possible zeros, the zeros of the function are 6 now, and these are the remaining ones. Okay, so for next question, we have a parcel and the sides are x, x, and y. We're given the volume of the parcel. let's first of all see what is the formula for volume of a parcel. That's width times length times height, which are x, and y. And it's given that it's equal to 11,000. Now the question is asking us to find the surface area as a function of x. So that means we should not have y here. So the first thing that I'm going to do is simplify this and get the y by itself. So divide both sides by x squared, these two cancel, and I'm going to have y equal to 11,000 over x squared. So far I have y with respect to x. Now I need to find the surface area. Surface area is the sum of all the surfaces, area of all the surfaces. So we have 6 different surfaces here. We're going to find the area of all of them and add them together. So the top and the bottom surfaces are just 2 squares, and the sides are x and x. So the area of that will be x squared. The other ones, the one on the right and the left side, front and the back side, they are rectangles. The sides are x and y. The area of a rectangle is just length times width, which is x times y. And we have 4 of them, so 4x times y. This is the surface area. However, we have y here, but we need to write that as a function of x. So change the y using this expression that we just found. So this will be, oh, and also I forgot that on the top and the bottom we have 2 surfaces, so I have 2x squared, 2 squares here. So the equation will be 2x squared plus 4 times x, and the y is 11,000 divided by x. Simplify. The x on top and the one of the x's in the bottom cancel. I will have 2x squared plus 4,4,0,0 divided by x. Now combine these two. The denominator is 1, but I need to find a common denominator, which is x. So multiply this one by x, top and the bottom by x. We'll have 2x to the power of 3 plus 4,4,0,0 divided by x. So this is the function of s of x, which is the surface area as a function of x. Then it's asking us to graph the function. To graph the function, I'm going to use my calculator and enter the function into y equal. So that's the function that I entered here. Now, to simply graph it, however, we need to consider and make sure the window is big enough. So this is the window that I created from -10 to 100, because I had really big numbers here. And the y max is from 0 to 1200, because I had a big number here. I can choose anything else. I could choose 55,000 because I have a really big number here. And when I graph it, this is what I have so far. But the window that is the question is asking us are these numbers. So I'm going to change the window to what is given to me. So the window is from 0 for x min. X max is 100. The scale is 10. And then the y min is 0. Y max is 8,000. And the y scale is 1,000. Now I graph it, and it looks like this one. This is the graph of the function. Okay, next, it's asking us to find the minimum amount of the material. To find the minimum, you're going to go to second trace and go to minimum here. And you need to move the cursor to the left side of the minimum point, and then go to the right side, enter, and move almost to the top, enter, and it's going to give us these values. So this y value is the minimum material that needs to be used, and this x is the value of x that minimizes the surface area, and then we're going to find the y after that. So let me write these values first here for you. This one, because it says round to the nearest square inch, this will be just 2968, and the x value which minimizes is 22.24. Now, how do I find the y value? Just use this equation. Y will be 11,000 divided by x squared, which is 22.24 to the power of 2. So I'm going to use my calculator for that. And when you divide it, it's equal to this number. And just round it, that's going to be 22.24. So we notice that when x and y are equal to each other, then we can minimize the amount of the material that we're using. Okay, next question is asking us to use the rational zero theorem. So again, we just need to find factors of 3 and factors of -9, the leading coefficient and the constant, and divide them by each other. Make sure you consider the positive and negative cases as well. Factors of 3 are 1 and 3. Factors of 9 are 1, 3, and 9. Now, divide them 1 by 1, 1 by 3, 1 by 9. Then 3 by 1, 3 by 3, and 3 by 9. Make sure you remove the ones that are repeated. 3 by 3 is 1, which is already here. 3 by 9 is 1 over 3. That is already here as well. So we don't need them, and we're going to write these, but consider the positive and negative, and that's the answer. Notice that for this question, you cannot use your calculator because the question is asking us to use rational zero theorem. So you have to show your work on your test. You have to show your work. You have to do all these. Do not just directly use your calculator. Okay, next question. We're given this graph of a rational function. First, we want to find the domain. So for the domain, we know that we need to move from left to the right and look for the x value. So I move from left to the right. The first part of the function is coming from -infinity and ends at this asymptote, which is at x equal to -6. So the first part is from -infinity to -6, and I use parentheses because this is an asymptote. So we have to use parentheses. Then the second part is this one, which is coming from here and ends at this asymptote, which is at x equal to 6. So it's going to be from -6 to 6. And the third part is this one, from 6 to infinity, because it's going to continue. So this is the domain. How about the range of the function? To find the range, you're going to move from bottom to top and look for the y values. So start from bottom, you're coming from -infinity and going and stop here. So it's from -infinity to 0. That's the y value of this point. But the 0 is part of the function. It's a point here that is part of the graph. So I use bracket. And then the next part starts from here, from the horizontal asymptote, which is at y equal to 3. So starts from 3 and goes to infinity. It's going to continue. And 3 is a parenthesis because we have an asymptote here. Okay, what are the intercepts of the function? We have only one intercept, which is at this point, and it's at 0 and 0. The horizontal asymptote, as we talked about, that is this line, it's equal to y equal to 3. Okay, next, what is the vertical asymptote? We found them. They were at x minus 6 and x equal to +6. And there was no oblique asymptote here. Next question, we want to solve the inequality. The first thing that you need to do is move this to the left side. So you will have 4 over x minus 9 minus 8 over 5x minus 3. Now we need to combine them. We don't have the same denominator, so we have to find the common denominator. Since they don't have anything in common, to find a common denominator, you just need to multiply those two by each other. So common denominator is x minus 9 times 5x minus 3. Now, since you have multiplied x minus 9 by 5x minus 3, you have to do that to the top as well. Multiply by 5x minus 3, because you did that to the bottom as well. So the top will be distribute. 4 times 5x will be 20x. 4 times negative 3 is negative 12. The second one, this is multiplied by x minus 9. You do the same thing to the top as well. And since I have a negative here, so I combine that. Negative 8 times x is negative 8x. Negative 8 times negative 9 is 72. Now combine the like terms. 20x and negative 8x will be 12x. And negative 12 plus 72 is 60. The denominator is x minus 9, 5x minus 3. And this whole thing should be greater than 0 because we moved this to the left. Okay, now it's time to solve this. First, you're going to set the top equal to 0 to find the 0 of the function. 12x plus 60 equal to 0. And x is 60 over 12, which is basically negative 60 over 12, which is negative 5. And then the denominator should be not equal to 0, not equal to 0. Because if you have a fraction, if the denominator is 0, the fraction is undefined. So not equal to 0, and x is not equal to 9. Next one, 5x minus 3, not equal to 0. So x should be not equal to 3 over 5. Now, I'm going to make my number line and label the zeros or all these numbers. So it was negative 5, 3 over 5, and 9. Put them in order. Now, you have to try numbers before, between, and after these ones. So I can try negative 6 here, 0 here, 1 here, and 10 here. So you need to find the polynomial, the value of the polynomial or the rational inequality when x is equal to negative 6. So I'm going to call this f of x and find f of negative 6, f of 0, and find those values and see if they are positive or negative. When you plug in negative 6 here, this will be 12 times negative 6 plus 60 over negative 6 minus 9, 5 times negative 6 minus 3. When you calculate, this is going to be equal to negative 12 over 495, which is a negative number. So any number before negative 5 makes this expression negative. Now find f of 0. When you calculate, it's going to be equal to 60 over 24, which is positive. F of 1 will be equal to 60 over negative 18. It's negative. F of 10 will be 60 over negative, it's going to be 180 over 47. That is positive as well. So what are we looking for? We're looking for the part of the function which is greater than 0. So this part between these two and between this area. Now write the answer in interval form. From here to here will be from negative 5 to 3 over 5. And I put parentheses because I have only greater than 0, not equal. And the second part will be 9 to infinity. Since it's asking us to write interval notation, we have to use a union sign between them. Next question is asking us to find the domain of the rational function. If you have a rational function, to find the domain, you just need to set the denominator not equal to 0 and solve for x. So x to the 3 plus 64 equal to 0. Subtract 64, x to the 3 equal to negative 64, and then take the cube root of both sides. Left side is x and the right side is negative 4. So it should be not equal to negative 4. So the domain will be, if I use my number line, negative 4 is the point that we don't want. Everything before that and after that are acceptable. So from negative infinity to negative 4, parentheses, and negative 4 to infinity. This is the domain of the function. Okay, so for next question, we want to find the complex zeros of the function. The first thing that comes to my mind is factor this function. I see x to the power of 4 and x to the power of 2 and a constant term here. I'm going to use substitution. That means choose a new variable and substitute for x. What is a new variable? I'm going to choose something like u. You can name it anything else. And set u equal to x to the power of 2. And if raise both sides to the power of 2, I will have u squared equal to x to the power of 4. So replace the x squared and x to the power of 4 with these two. The polynomial will look like x to the power of 4 is u squared, so write u squared plus 26 times x squared, which is u, plus 25. Now this looks like a normal quadratic function. So I can factor using this method. Find two numbers that add up to 26 and multiply to 25. What are those two numbers? They are 25 and 1. Now I can write u plus 1 and u plus 25. Now I have factored this. I'm going to put the variables back here. So u was x squared. So this is x squared plus 1. And here this will be x squared plus 25. I have two factors. Now to find the zeros, set each of them equal to 0. So one of them is x squared plus 1 equal to 0. So x squared is equal to negative 1. Take the square root of both sides. The left side is x, right side will be positive square root of negative 1 and negative square root of negative 1. And we already know square root of negative 1 is equal to I. So positive I and negative I. These are two zeros. Now the other one. X squared plus 25 equal to 0. Subtract 25 and x squared will be equal to negative 25. Take its square root of both sides. X will be equal to positive square root of negative 25 and negative square root of negative 25. Square root of negative 25 is square root of negative 1 times the square root of 25. Square root of negative 1 is I, square root of 25 is 5, so I can write that here. The same is here. So I have negative I and the square root of 25 is 5. So the roots are I, negative I, 5I, and negative 5I. Okay, this was the last question of chapter 5 review quiz. I hope this was helpful for you. Good luck with your test.